This is an intro to mean value theorem with integrals. In this video, I'll go over how to use the mean value theorem to find a value of c given a function using integration. And so whenever you come upon a question that requires you to use the mean value theorem with integrals, it'll come in this form, where a function is given to you and a closed interval paired with that function is also given to you. And so in this question, our first step, or part A, is to verify that all the conditions of the mean value theorem are satisfied for the function on the given equation. And so what that basically means is the mean value theorem, or MVT for short, can only be used when two conditions are met. One, the function must be continuous on the given interval. So on the given interval 1 to 3, the function must be continuous. And the second condition is that the function must be differential on that same interval. So the function f of x equals x squared should be differentiable on the interval 1, 3. And so to verify this, we can look at the function given to us, x squared. And so an easy way to find out whether it's continuous or not is to check whether it's a polynomial or not. In this case, it's a polynomial, and most, if not all, polynomials will be continuous. And so on this given interval, it will be continuous as well. So that means out of the two conditions, the first condition, or being continuous, is checked off. And now the second condition, whether it's differentiable, we can check that by plugging in a value inside the interval. So in this case, a value inside the interval would be 2, because the interval is 1 to 3. And so when we plug in that value into the derivative of f of x, so to find the derivative, all we need to do is do f prime of x and use the power rule to get this, 2x. And if you plug in a value from the interval, in this case we got 2, and that gives us 4. And so if the value you get after plugging in a number is real, in this case 4 is a real number, that means the function given to us is differentiable. And so now that both of our conditions are met, we can use the mean value theorem. And part B asks us to find the value of c guaranteed by the mean value theorem for the function f of x on the interval 1, 3. And so using the mean value theorem, there is just one equation that you need to, or one formula that you need to memorize for the mean value theorem. And it comes from the fact that the original mean value theorem is that the instantaneous rate of change is equal to the average rate of change, given that the function meets the two conditions, and the two conditions being continuous and differential on the interval given to us. And so using that fact, we can modify it to use the mean value theorem with integrals. And so when we do that, we get something along the lines of this. F of x dx, an integral from a to b of f of x dx, is equal to the function f of c times b minus a. And so what this basically means is that the instantaneous rate of change is equal to the average rate of change. And so whenever you encounter a question relating to mean value theorem using integrals, it's important to memorize this formula. So now that you've memorized the formula, you can now use this formula to find the value of c, what the question is asking you to find. And so before using this formula, it's important to identify what a and b are. And so what a and b are, it's basically the interval given to you. So in this case, it's 1, 3, which is the interval. And so a and b are simply these values. This is A and this is B. Okay, so the initial value is A and the last value is B. So now knowing that, we can now input into our formula A and B. So A is 1, B is 3 in this case. And f of x is just the function given to you. So f of x is equal to x squared in this question. Dx equals to, and now f of c. So f of c is what we would get once we plug in c into the function. So if you plug in c into this function, which is x squared, f of c would be c squared because we replaced x with c. So this would be c squared, and now b, which is 3 in this case, minus a, which is 1 in this case. And so now you have everything you need to find the value of c. And before doing that, we need to integrate this left-hand side. And so using the power rule, you can get x cubed over 3 evaluated from 1 to 3 equals to c squared. 3 minus 1 is 2. And now when we plug in 3 into x cubed over 3, we get 3 cubed, which is 27 over 3. 27 over 3, which is 9. 9 minus 1 cubed, which is 1 over 3. So 9 minus 1 over 3. So when you get 9 minus 1 over 3 in fraction form, that would be 26 over 3. And that is equal to c squared times 2. And now we can simply solve for c, and we would get 26 over 3 divided by 2. So 26 divided by 6 equals c squared. And so c would be the square root of 26 over 6. And so this is the value of c guaranteed by the mean value theorem in this interval and this function. So in this question, we have a function and we have a different interval. And our first part is to verify that the condition of the mean value theorem is satisfied on this interval. And so two conditions. The first condition is it continuous. And so when you look at the graph of the square root of x, it looks like this. And so we know that that function is continuous because there is no break in that function. And so since you know it's continuous, the first condition is met. Now the second condition is it differentiable. Now to find out whether it's differentiable, we need to find the derivative of this function. So f prime is equal to 1 over, because using the power rule, we get 1 over 2 times the square root of x. And if we plug in a number in the interval given to us, in this case you can use 2 again, we get f prime of 2 equals to 1 over 2 times the square root of 2. And so the point being, this is a real number. And so since it's definite and it's not undefinite, we know that it's differentiable. So that means the second condition is met as well. So now since both conditions are met, we know that we can use the mean value theorem for this question. And now, like the previous question, it's important to understand the formula. So it's an integral from a to b of f of x dx, and that's equal to f of c times b minus a. And now again, the values of a and b are simply the start and finish number values on the interval. And so in this case, when we plug it in, we get 1, 4. And the value of the function f of x, it's given to us, the function f of x is equal to square root of x. So you can plug this in here. And f of c, if you plug in c into this function, we simply get the square root of c times b minus a, 4 minus 1. Now all we need to do is solve for c, and to do that we need to first integrate this side. And when we integrate this side, we can use the power rule first. First I'm going to rewrite it as x to the power 1/2, and then I'm going to use the power rule. So you get x 3/2 divided by x to the power 3/2 divided by 2/3. 3/2 divided by 3/2, so you get 2, 3. So this evaluated from 1 to 4 is equal to the square root of c times 3. 4 minus 1 is 3. And so now from here we can just plug in 4. If you plug in 4, 4 to the power of 3 over 2 is 8. 8 times 2 is 16. And so we get 16/3 minus 1 to the power of 3/2 is 1. And that means 1 times 2 is 2. 2/3 is 2/3. Now 16 minus 2, 14. So we get 14/3. And now all we need to do is plug this back in. 14/3 equals to the square root of c times 3. And so when we solve for c, we get 14 divided by 9 equals square root of c. And if we solve for c, we can square both sides, and we get 256/81. And that is the value of c. So that's the value of c guaranteed by the mean value theorem. In this question, we have the function f of x equals e to the power of x on the interval 1, 3. And so first things first, make sure that we can use the mean value theorem and verify the conditions are satisfied. So if you look at the function e to the power of x and you make a graph of that equation, we get something along the lines of this. So you can use a graphing calculator, but it looks something like this. And to the point being, there is no breaks in this graph or any asymptotes. So we know that this function is continuous, which means that the first condition is met. Now, the second condition, is it differentiable? To do that, we need to find the derivative of the function given to us. And so f prime of x is equal to e to the power of x. And f prime at a number in between the interval, in this case you can use 2 again, it would be e to the power of 2. And so since this is a real number, it's definite, it's not indefinite, this means that it is differentiable. And so since both conditions are met, we can use the mean value theorem. Again, the mean value theorem is a to b, the integral from a to b of f of x dx, and that's equal to f of c times b minus a. And now when we plug in a and b, if you plug in a and b, in this case a is 1, b is 3, plug in f of x, which in this case is e to the power of x dx, and that's equal to f of c, which is, when you plug in c to this, which is e to the power of c, times b minus a. And b is 3, a is 1, so b minus 3 is b minus a is 3 minus 1. And so now all we need to do is integrate the left-hand side. When we integrate the left-hand side, e to the power of x is easy, because the integral of e to the power of x is simply e to the power of x. Right? And so e to the power of x, evaluated from 1 to 3, is equal to e to the power of c times 2. If we plug in 3 into this equation, we get e to the power of 3 minus e to the power of 1, and we get e to the power of c over 2. Now, the natural log of e is going to be 1. And so, if you know the natural log of e is 1, we can just take the natural log on both sides. And so if you take the natural log on both sides, we would get something along the lines of e to the power of c equals to, first let me divide both sides by 2 so that we can get everything on one side, e to the power of 3 minus e over 2. And then if we solve for this, we get the natural log of e to the power of 3 minus e over 2. And so that's the value of c guaranteed by the mean value theorem. So in this question, we have the function f of x equals sine of x on the interval 0 to pi. As always, the first step is to find the conditions and see if it's satisfied. So when we graph the function of sine of x, we get something along the lines of this, right? And so what this means is it doesn't have an asymptote and it doesn't have any breaks in the graph, so it's continuous, right? And so that means our first condition is met. Second condition, is it differentiable? So if you take the derivative of this function, the derivative of sine of x is cosine of x. So f prime of x is equal to cosine of x. And if you plug in a value in between, say for example cosine of pi over 2, now the cosine of pi over 2, it's a real number. It's cosine of pi over 2 is approximately 0. So this is a real number, and so we know that since it's definite, this function is differentiable. And so since this function is differentiable, our second condition is met. And so since both of our conditions are met, we know that we can use the mean value theorem. And so the mean value theorem is from a to b integral of function f of x dx, and that's equal to f of c times b minus a. If we plug in everything, a is our first number in the interval, 0, and then b is pi. F of x is sine of x dx equals f of c. If you plug in c into the function, we get sine of c. And that times b minus a. And b minus a is pi minus 0, in other words, pi. Now, all we need to do is solve for c, and first thing we need to do is integrate the left-hand side. The integral of sine of x is cosine of x. Actually, it's negative cosine of x. Yeah, because the cosine of x, the derivative of cosine of x is negative sine x, and negative cosine of x is sine x. And that's evaluated from 0 to pi. That's sine of c times pi. Now if you plug in our pi, we get negative 1 times negative 1, which is 1, and 1 minus cosine of 0. Cosine of 0 is simply 1. And so 1 minus minus 1 is 2. So now if you plug it back in, I'll write it in red, we get 2 equal to pi sine of c. And if we solve for c, we get 2 over pi equals sine of c. Now c is simply sine inverse of 2 over pi. And using a calculator, if we want to find the sine inverse of 2 over pi, we can do that, and we get 0.7 approximately. So c is equal to 0.7. And so that's the value of c guaranteed by the mean value theorem for this function on this interval. And so it's easy to use the mean value theorem with integrals. All you need to do is verify that the two conditions are satisfied, and you remember the formula. The formula being the integral of f of x from a to b is equal to f of c times b minus a. And if you solve for c, you should be getting the value of c guaranteed by the mean value theorem.